this case, we are going to continue on our straight lines looking into the gradient of a straight line. So basically, if you refer to the gradient, something that we talked about before, which simply represents how steep the slope is, that is the steepness of what? The steepness of the slope. And previously, I explained about lines of this nature, which have got a positive gradient, and lines of this nature which do carry a negative gradient. But we didn't explain now on how to determine that gradient. We just expressed, all right, if you say a line like this, it has got a positive gradient. When it is like this, it has got a negative gradient. So how do you calculate that gradient? Using points or given points, like what we're given here. Find the gradients of the lines joining the points. So from that steepness of the slope that I've been talking about, the gradient simply represents the change that happens in the y and the change that is going to happen in x. So it is the change in y and also the change in x that gives us the gradient, the steepness of the slope, which can be represented in different manners. The change in y, the change in x, all right? Something of this nature. So that is we can simply say that gradient representing the steepness of the slope is simply the change in y over the change in what? Over the change in x. So that change in y is affected to say, let's say there is a point here which we refer to as x1, y1 like this, and there is a point here which we refer to as x2, y2 like that. So the change in y is the difference that we have on the y values, because what you'll be having, it will be like this here on the y values. This is going to be y1 and this is going to be y2. This is corresponding to y1, this one to y2. So the change, that is y2 minus what? y1. So that's y2 minus y1, which some, they use y1 minus y2, which is not a problem, all right? Over what? The change in x. Here the x value is corresponding to x1. Here the x value is corresponding to x2. So the difference between these 2 points is what? The change in x, x2 minus x1. So that's basically your gradient in short. So the gradient is given or can be taken from this formula, where that gradient is represented by the letter m. All right, the gradient is represented by the letter m in mathematics. So when we write the equation y is equal to mx plus c, this m is our gradient, the one that was calculated from this formula. Or you can use the formula having y1 minus y2. So you can write it y1 minus y2 over x1 minus x2. So you must be very careful about the formula. If you start with a 2, make sure also the denominator starts with what? A 2. If you start with a 1, make sure that in the denominator, you start also with a 1 on the x values. So not to confuse you guys, I'm going to use this formula so that we do not confuse each other. But if you prefer the first one, I mean the second formula, then use it. It's not a problem. So this is basically the gradient. Given 2 points, you can have that gradient. So this formula is actually used when given what? When given 2 points, it is used when given what? When given 2 points. All right, like what we're given here. So there are other ways where, or there are other specific presentations where we can be asked to find the gradient. We can also do it by movement, by this illustration, change in y over change in x. But when you're given points like this, there's no need for you to represent the points like here, and just use the formula. All right, so A, find the gradients of the lines joining what? Joining the points, all right, 1, 3, and so on. So the first one is 1, 3, and 4, 9, like this. So this is what you're given. And what we need is to find the gradient. So what we're going to do is to simply name our points. The first point, the second point. The first point, x value is going to be x1, the y value, y1. here x2, second point. So this is going to be y2. Remember, a point is given as xy. So the 1 is for the first point, all right? 2 for the what? Second point, according to the way that you want to name your points. Is this your first point? Is this your second point? You name the way that you want, all right? So anyways, let us determine our gradient from this formula. So the gradient is what? The change in y over the change in x. So that simply means we are going to substitute y2 is what? 9 minus y1, which is 3, over what? x2, which is 4, minus x1. The x1 is what? Is 1. You substitute the value as it is. So that was going to give us the gradient of the line. 6 minus 3, that is going to be, 9 minus 3, that's going to be 6. And this is going to give us 3. And divide, that's there, 2. So our gradient is 2. Let us save our calculator, guys, to verify. You know, guys, the mind somehow can have these calculations done in another way. 9 minus 3 over what? 4 minus 1. So that's a 2, okay? So this is it. You have got your gradient from there. Let us move on to another one. So you can try using another formula and see. You're going to have the same answer on that. All right, so B, using the same concept on this one. So this will be our x1, y1. That's our first point. And x2, y2, our second point. So our gradient, as I said, you can use the letter M to represent the gradient. y2 minus y1, guys. You're just going to rewrite your formula here. All right. Anyways, y2 is what? Negative 3. The sign is a negative. Minus y1 is what? Positive 3 over x2, which is 6 over what? x1, that is 2. So this is it. Minus 3, that's minus 6 over what? 6 minus 2. That is going to give us a 4. Then you can simply reduce by 2. That's 2 here. And this is going to be negative 3. So you can actually have your answer as negative 3 over 2 or negative 1,5, negative 1.5. So as a gradient, you can even leave your answers as improper fractions. It's not a problem for the what? For the gradient. All right, let me just verify here. 6 minus 2, which is what? Yes, minus 3 over what? Minus 3 over 2. So just like that, this is your gradient. And the last one here, let us use these points to determine our gradient. So this is our x1, y1, x2, y2. So C, our gradient is going to be what? y2 minus y1 over x2 minus x1. So y2, that's 10 here. All right, minus y1, it's negative 8. So take note, the minus here is of the formula, but what you are subtracting here is carrying a negative. So just put that one in a bracket like this. All right, over what? x2 minus x1, or x2 is what? Is 4. So that's 4 minus x1. It is also carrying a negative, so put that in a bracket. So do not confuse the negative of the formula, this one of the formula, and the negative of the number. The number is carrying its own negative. There is a negative of the formula, all right? So anyways, negative, that's positive here. So it's going to be 18. 4 plus 2, it's going to be 6. And divide here, you're going to obtain 3. 18 divided by 6, that's 3. All right, so let us just also use our calculator to verify everything. But that is it for the gradient. So 10 minus 8. All right, everything over 4 minus, what are we subtracting? Minus 2. So that was going to give us a 3. Exactly what you have. So that is how you play around with these questions on the calculation of what? Of the gradient using the formula. So like I said, there are so many ways, or there can be other questions which will be given from the equation of a straight line graphically, but when you are given points, or where you can visibly see the points, write down the points like this, then determine your gradient from what? From the formula, just like that. All right, so we shall meet again, guys, working with other aspect of our straight lines up to the end. So that is it for now, till we meet again.